All right, so this is the last of our required learning objectives. So if you made it this far, all right, you're learned everything you're going to need for the exam. And you'll see this has the 3 in front, so this is related to the law of sines. But it's a completely different law. It's the law of cosines. So although it's kind of similar in that we're working with non-right triangles, it is a different formula. All right, so here is the law. All right, so again, we had this kind of setup where the angle alpha is across from A, the angle beta is across from B, the angle C is across from this angle gamma. All right, we get these 3 different formulas. All right, you look at the first part. The first part looks really similar to the Pythagorean theorem, a squared plus b squared equals c squared, or something along those lines. But these are not right triangles, so the kind of way we correct the fact that it's not a right triangle is we add, or actually subtract, this last term here. Again, just like always, you don't need to worry about memorizing these formulas. I know that they do exist. There's a way to relate the sides of a non-right triangle, but you do need to know some information about your angles as well. All right, so this is the law of cosines. One thing you can see is that the side and the angle only come up once, and all the other sides come up. So if I know this thing about the angle alpha, all right, that corresponding side is only going to come up once, and all the other sides come up multiple times. All right, so you can kind of use this to your advantage about where you're going to, or which of these kind of 3 you're going to use. All right, so keep these in mind, all right, as we start working on the examples. All right, so again, we want to complete the triangle. So we want to figure out the angles and the sides of this triangle. All right, so half of it's done. We have 2 sides. We're missing 1. We have 1 angle. We're missing 2. But as we kind of saw, as I mentioned, that these things are related to the angle across the triangle. So if I kind of write this, this is going to be b squared. I'm going to end up using the middle formula, is a squared plus c squared. And my correction term, 2ac cosine of beta. The only thing I don't know in this problem is what is b squared. Right, a we know is 10. Right, c we know is 12. I'm just going to put all this in. And beta we know is 30. All right, in this specific case, we actually know what cosine of 30 is using our unit circle, but most of these are going to have to use a calculator. So we'll just end up using a calculator. All right, type all this in. All right, so let me pull up Desmos and type all this in. We got 10 squared plus 12 squared minus 2 times 10 times 12. Oops, if I can type correctly. And that's all times cosine of 30. All right, so if you type all of that in, all right, you end up getting that the whole right-hand side is equal to 36 point, let's just do 1 decimal place, 36.2. So that whole right-hand side we have all the values for. We can just put it into a calculator. Again, if you're typing it in kind of a traditional calculator, be careful with your parentheses and multiplying and everything. But now I can figure out b by just taking the square root. All right, I'm going to get my final answer. B is whatever the square root of 36.2 is, and that's 6.0. Right, so my b value in this case is 6.0. All right, so we use our law of cosines. The side that we're trying to find is kind of the side that's going to go by itself. Hopefully we know everything else on the right-hand side. But now that we know b is 6, we can try to find one of our angles. Okay, let's just try to find the angle gamma. We know if we want to use the angle gamma, the side that's going to go by itself is the one across from it, which is 12. So this is going to end up being the bottom formula, which I'll write down real quickly. And again, we know a lot of this stuff. Now we know C is 12, A is 10, B we just figured out is 6. But this problem's a little bit different because we can't just type in the whole right-hand side, because one of the things we don't know is what gamma is. But what we're going to end up doing is getting cosine of gamma by itself, and then we can use inverse trig as to our advantage. So what I'm going to do first is subtract these two numbers to the other side. I'm just going to use a calculator right away to kind of help me. So I'm going to have 12 squared on the left. I'm going to subtract 10 squared from that, and I'm going to subtract 6 squared from that. And that's going to be 8. All right, that -2 is still there. Now I want to get this cosine thing by itself. So I'm going to do is divide everything by -2 times 10 times 6 on both sides. All right, so I have 8 divided by -2 times 10 times 6. Oops. And that's going to be -0.067 equals cosine of gamma. And then the whole point of getting to this point was if I get cosine is equal to a number, I can switch these two things. If I switch to cosine inverse, all right, these two things are going to switch places. And that's going to be equal to this angle gamma. And now I just type this into the calculator. Arc cosine, or cosine inverse, -0.067. And that gives me that this gamma is a 93.8 degree angle. All right, so I just use the law of cosines. I kind of put everything in where it goes and then just solve and use inverse trig to get the answer. And then, of course, I could find alpha because it's just subtracting the two angles I know. Which if I use a calculator again, 30 minus 93.8. Yeah, alpha ended up being 56.2 degrees. All right, so new formula, new law of cosines. All the formulas look a little bit similar. It's just kind of the angle and the side you care about are kind of on opposite sides of these formulas, and the other sides are in the middle. I would kind of just put in what you know and solve for what you are trying to find. Again, it might be a little bit of trying out at the start to make sure you pick the right of those three equations, but there should be only one thing you don't know in that equation. Everything else you should know the value of. So in this first example, the only thing we didn't know was this b. We knew the value of everything else. In our second example, the only thing we didn't know was this gamma, and we knew the value of everything else. So as long as there's only one thing you don't know, you can figure out what that thing is. All right, so your example, you don't have to go through the whole thing, but you have to find this value of x. And this is the answer I came up with. So I used, again, the x is by itself because the 72 is what we want in the cosine. That whole right-hand side, put in a calculator. All right, take the square root of both sides, and you get 6.9 as your answer. All right, in this case, we want to find the value of a. So we don't have to do, again, complete the whole triangle. We just want to find the value of a. All right, here they're not labeled A, B, and C or anything. All right, but if we're finding the value of A, we know the thing that goes on the opposite side of the equal sign is the one across from. So the 2.3 is going to be the one that goes over here. The other two sides doesn't really matter because you just add them. Subtract 2 times those things being multiplied. And then cosine of A. All right, so I'm just following the formula for the law of cosines, knowing that the angle I care about and the side that are across from each other kind of go in the opposite ends of that formula. All right, just like we did before when we were trying to find the angle, the first thing we do is subtract those to the other side. So I'm going to type that in the calculator, 2.3 squared. I'm going to subtract 1.5 squared and subtract 2.5 squared. That turns the left-hand side into -3.21. That's equal to what's left on the right-hand side, the two things I haven't, or that whole thing I haven't changed yet. Then I have to divide both sides. I'm going to be a little bit lazy, but this whole thing, I'm dividing on both sides, so I'm going to end up subtracting -3.21. I'm going to divide it by -2 times 1.5 times 2.5, and that gives me 0.428 equals cosine of A. And again, the whole reason I get the cosine by itself is now I can do cosine inverse of 0.428 equals A. And that's what I'm trying to find. I'm trying to find A. So I just type that in the calculator. 0.428. Again, double checking that your calculator is in degrees tells me this is 64.7 degrees. All right, so really, when you're trying to find this angle when you have the sides, I use the law of cosines. And again, when you're setting up the equation, you have to know that the angle that you're trying to find is on the opposite side from the side that's related to it. All right, so this is the law of cosines using to find an angle. All right, so your problem is similar. All right, find this angle A in this problem. Again, definitely the numbers are a little bit bigger, so definitely use a calculator to help you. And here's my solution. So again, angle I care about is A, and the side across from that is 125, so those goes on opposite ends of the equation. All right, move these things by subtracting, divide, and then use our inverse trig to get our final answer. All right, there's some rounding that's happened in this step and this step. So if you got 70.6 or 70.8, all right, that's all kind of reasonable depending on where you're rounding. All right, but with only kind of rounding these two steps, 70.7 is a fine answer for this problem. All right, and your final multiple choice question. All right, find x in this diagram. So now you're going back to finding a side length. All right, so again, do this multiple choice question, figure out the answer, and do the practice. Again, this is the very last required learning objective. All right, so now you're kind of prepared for what is going to be on the exam at the end of the semester. All right, but the farther learning objective is going to kind of help you understand this stuff better, kind of push you a little bit more past some of the learning objectives you already had, and towards the end kind of introduce a brand new topic as well that'll really help you in pre-calc and beyond. All right, so keep working through the learning objectives. All right, don't just stop now because you got to the last required one. All right, you want to kind of keep pushing yourself. All right, the more you learn, the more the easier stuff becomes simple, and that's going to help you when we get to the exam.